Well, welcome students. We're starting a new series of math concepts that has to do with what we call simplifying radical expressions, and we'll be doing this for about 2 or 3 weeks. Now, one thing I want you to realize here is that symbol right there is not long division. It looks like it, and that's where you guys are going to have a big issue. This is not long division. We're not dividing. This thing is called a radical, and it signifies what we call square roots. Now remember um, the idea behind long division. If you remember correctly, that's what the symbol for long division looks like. This is a new symbol. You probably haven't seen that often, and it simplifies taking a square root of something, and we'll be discussing that for the next little while, like I said. All right, so we're going to play a little math game here, and it's called poker pairs. No, we're not using playing cards. We're going to be using numbers. So anyway, there's going to be 3 rules to this, and the rules are pretty simple. The first rule is if there's 2 factors on the inside of the radical, they call it the radicand. If there's 2 factors on the inside, then 1 factor can come out. So that's the idea of the pairs. If you have a pair inside, one of those 2 pair can come out. Okay, the other rule, if there's 1 factor, just 1 factor on the inside of something, it stays inside. It can't come out. So 1 factor means that it stays inside the radical. And the last rule, let's get that in just a second. So the last rule is this. You have to simplify the outside, simplify the inside, and then you also have to simplify the outside. So you have to have 1 term on the inside and 1 term on the outside, and then we're good. Now this is building skills for the next stuff that we're going to do. So remember, this is the nuts and bolts of it. If you know how to do this, the rest of this stuff is going to be really, really easy. Okay, I'm going to go shrink that down so I have enough room to write here. And we're going to zoom in, and we'll do problem number 1. Now, one thing it says there in the directions is you have to do the prime factorization. And instead of using a prime factorization tree, we're going to use something I call a prime factorization spine. So instead of going up and down, this thing's going to go left to right. And we're going to start by checking numbers 2, 3, 5, 7, and sometimes 9. So if something's divisible by 2, we do it till 2's run out, then we check 3's. When the 3's run out, we check 5's, and so forth all the way to 9. So we're going to start with a 2 because it looks like it's an even number because it ends in 4. So let me get my calculator here set up. So 294 divided by 2, and use your calculator to do this. It's 147. Now that's an odd number, so I know it's not going to divide by 2, so I'm going to go ahead and start dividing by 3. And if it doesn't divide by 3, then I would check 5. So 147 divided by 3, that gives me 49, so it did work. So 3 divided to 147 gives me the 49. And I know 5 won't be divisible by 5, so I know that's a multiplication table of 7. So I'm going to divide 7 into that. So 49 divided by 7, and I get 7. Okay, so 49 divided by 7 gives me the 7. Now if you look there, you can see that I have a pair. I have a pair right there. I got a pair of 7s that's on the inside, and I have a pair. So there's my 2 7s. Now I have to look at the variable. See, I have an x cubed. Now we know that x cubed equals an x times x times x. So I get x squared. There's a pair there, and it says here 2 factors inside, 1 comes out. So now I'm ready to do that. So you can see the 7's come out. There's 7. 1 7 comes out. I have 2 x's on the inside, so 1 x comes out. There's my radical. And what's left inside, there's only one of those, 1 2 and 1 3, and I have 1 x. So they have to stay on the inside. So 2 times 3 times x is on the inside. Now I want to simplify this, simplify the inside. It's already simplified for me, 7x. And now I have to take 2 times the 3 is 6, and 6 times x is 6x. So that is the answer to that problem on number 1. So pretty cool, huh? Easy stuff, so do not get behind on this. If you get behind the rest of it, you're going to be toast. So you've got to learn this stuff right now, ladies and gentlemen. Okay, here we go. We're going to do our prime factorization on number 2. And again, we want to check 2, 3, 5, 7, and sometimes 9. Okay, we'll divide by 2. I can see that's an even number, so I divide 80 by 2, I get 40. 40 is an even number. I don't need to use my calculator on this. It's such an easy one. 20 divided by 2 is 10. I know that's divisible by 2. 10 divided by 2 gives me a 5. And look at all those I got. There's one pair, so a 2 can come out. There's another pair of 2, so another 2 can come out. You can see the 5's by itself, so it's going to stay. And then I have x equal x to the cubed equals x times x times x. So just like number 1, you can see that a pair of x's are going to come out, or there's two x's, so 1 will come out. Excuse me on that one. So let's go ahead and write it. There's a 2. There's a 2 that comes out for the first pair, a 2 that comes out for the second pair, and then I have an x that comes out for the pair of x's, and the 1 stay on the inside. So you see I have a 5, a single 5, and I have a single x, so that'll be 5x. So it looks like I need to simplify the outside. The inside is already simplified. So 2 times 2 is 4. Inside is simplified, so 5x. The outside is 4x. It's 2 times 2 is 4. So that's it. That's how you do this, and it's not too bad. And thanks for watching.